Hi everybody. So originally I was going to be doing the ring buffer video next, but I came across this issue yesterday where I was working on a logging for a different project, and I was just getting really annoyed with the way we'd implement it. Where basically like we have this, where every time I want to do some kind of formatting, I have to do STD format, and then that just makes for like a really long and verbose line. When really I want something like this, right? Where I can just ignore the format and it will just take care of it on the other side. So that's what we're going to be implementing today. Just putting this so that way we can do this, and format will be on the other side, meaning it will be over here rather than over here on the user of our API. Now the way we're going to do this is with something called forwarding references. And just to read it, forwarding references are a special kind of reference that preserve the value category of a function argument, making it possible to forward it by means of std forward. And we're going to be using that to pass our arguments over to std format. So the other thing we need is template args, and it's just like this. I think it's fine. So yeah, so this is pack. And basically what this is going to let us do is it's going to let us pack arguments. So in our example right here, right, this is going to be a C string, but this is going to be a set of packed args. And that's all we need to be able to get this going. So the first thing is, since we're going to be using templates, we aren't going to be using our C++ file anymore. So let's go into src, let's rm, well actually let's not rm it. Actually, all I really need is these, log.hpp, we'll do it right there. And then, yeah. And I recently learned about something else called std abort, which I didn't know about yet. And then we need to just include that. And then we need to include IO stream, and that'll be fine. Now it's giving us an ODR violation, totally fine. We'll inline it, and that'll solve that. We'll make this static, and that'll solve that. We no longer need to predefine those. And now what we're going to do is we have all these implementation details of like log info, log this, log that, but we're not actually going to be using we'll close that because we don't need it. We're not actually going to use these, so I'm going to do rmlog cpp cd dot, so we can get rid of that, and now we're in here. So what we're going to do is we're going to make one kind of like private, if you will, function, but we first need to templatize. Doesn't feel like a word now that I've said it out loud. And I'm doing this like underscore before it to mark it as private. If anybody using this code wants to call this like other thing to add different prefixes, they totally can. But we're going to make it private in the sense that we're telling the user you're not encouraged to use it, but if you want to, you totally can. So this is going to be a helper function, which these ones are going to call. And they're going to use this log. They're going to give the prefix. So in our case, like it could be debug or it could be info or whatever. Doesn't really matter. People can do whatever they want. Then we'll do a const char c string stir. And then this is where we're going to use those templates. We're going to use a forwarding reference. We're going to use packing so we can have some number of arguments. And then what we need to do is we need to handle the case for when we have at least one argument and when we have 0 arguments. And the way we can do this is we can use this if const expr. Let's look this up so you can see it. Expr, right? I don't want to do the Google version. Sorry, I don't know why I did it. So the statement that begins, becomes a const expr, const expression. And basically what this is doing is this is running at compile time. And so it returns the statements and discounts, so it deduces the type from int star, deduces the type to this. And so this is just running at compile time. Okay, so, and then what we want args is greater than 0? If so, right, we're going to do one thing, and if not, we're going to do the easy one, which is log file prefix stir and L. And then we can do log file dot flush. Super easy. And now we can get to the other version, which is log file prefix, and we're going to use a slightly different version of format. We're going to use something called V format, and I'll talk about that in a second. Make format args, and then what we're going to do is we're going to pass it the args, and we can do that because we did forwarding references. So there's two functions to look up. First, let's do std : v format and why we care about it. Okay, so this is a format string, and the reason that we care about it is that it allows us, if I'm not crazy, where is it? Where is it? So yeah, an object that represents the format string, and then we'll compare it to format, and an object that the format consists of. What I'm looking for is to state the exact difference, which is basically that it doesn't have to be a string at compile time for V format, because that can be like a security problem. I think we ran into that already. But you can kind of see in the notes, I'm just not finding it in the documentation where there's a difference. But I'm going to just leave that to other people to find, because it's a video and we need to keep moving. The other thing to look at is std make format args. This is fine, it'll work. Okay, so what this is doing is it's returning an object that stores an array of formatting args that can be implicitly converted to this, which is going to be used by vformat in our case to actually print everything out. So now what we can do is we can actually implement. Now, if we did the easy thing like this, I hope you already are seeing what the problem is. So that's our prefix. Then we can do stir. And then the problem is we don't have any args. So this is where we have to basically do this, and I'm just going to put this right here for everything real quick. And then what we get, and well, yeah, there's one other thing too. Let me do some formatting, stir, and then what we need to pass it, right, are args, boom, 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 args. And then we can pass it by doing a forward, nope, not forward is tuple, forward args, args. And that should be okay. So let's see what's, oh, I didn't name this, stir. And then what's wrong with this? Oh, so I'm not using, I'm making a mistake. That's fine. And I'm making a mistake in that I'm not doing that. Cool. So there we go. Now we're forwarding the args and we're marking that it's packed, and that is good. So let's do those for the rest. I think it's easier to just do like debug this, that. So really what we want to do is just like rewrite the whole, each one individually, I feel like. So I'll drop this, I'll put in an error, put it in this. I know this is fatal. And so the other thing to add here, because it's fatal, is std abort, and we can also tell the compiler something, which is that this function does not return. It's probably not necessary, but you don't want to tell the compiler that this thing, if we get here, it will never return. It's going to break the control flow. Okay, so the next one is we could do error, but I talked a while ago about how really we want to do like more verbose naming just to see what that's like. see if it makes the code easier to read. So we're going to do a full error, we're going to do a full warning, we're going to do a full warning, and that takes us to debug. I kind of hate that being in that position. I kind of think it should be like there. Totally meaningless. It's just for me, and I guess for you. All right, so there's our improved log statements. We haven't actually tested to see if they're working. So let's handle that. Actually, we'll Google this real quick so we can be on the same page. So basically, this indicates that the function will not return control flow to the calling function after it finishes. For example, functions that terminate the application, which is our case. This attribute applies to the name of the function being declared in function declarations only. So there it is. I kind of wish this documentation would say not just when to use it. So in our case, we're throwing an error, we're doing std : abort, but I kind of wish it would say why you should be doing this. So like, does it make for better code for the compiler or whatever? Anywho, so let's go to this. Not format. And every single case of this, right, we're just going to do this. We got rid of that. And now we can get rid of this annoying C string. And I think already you're seeing the benefits. That's just a lot cleaner looking. So we go to here now. We can drop this. And I think we can just make this one line now. Let's add a space there. Oh no, it's that. And it's technically over by 1 because it's 83, or over by 2 because it's 82 rather than 80, but I am okay with that. So we'll go to these next. Delete these. Cool. That's gone. Now we can go into here. And our code is getting a little bit better, which is always good. I hope. This is going to be too long regardless. So what we'll do is we'll do this, this, and that's fine. So now that takes us to this one, log warn. That's not going to be too long, I don't think. Could be wrong. The switch does take it kind of far out, but it's only 82. The other problem now is this is warning, not just that. And let's start doing this style where you have it at like the cases are part of the switch, and then that makes the lines a little bit easier to read anyways, now that I see it like that. Yeah, that's just better. I don't know why I wasn't always doing that. Sorry if that just made a sound when I hit the mic. Was not on purpose. Okay, so we go here. Now we can go to Sokoban. We can get rid of format completely. We can get rid of this unused library, and we can get rid of C string. A little better. Now we go here, G space, there. Now it's even better. Now we have this error right here because we're not using error. We have this other error because we're not using error, but we also have this nonsense, so we can get rid of that. And I think this is going to be a little long of a line, but it 100% is. Now we do this, and let's look at it. It's a little over, but we'll live. And that's that. So let's make it, see if it works. We have a couple errors. Application state 14 error, and you can see it does work now for no arguments. And then we should also, just because, and then we can also do this. Now we can make it, and all right, that worked. Now we can do Sokoban. We'll play. We'll beat a level. Oh, I can actually show some of the levels I made. So there's level 2, or level 1, I guess. This is a level that's very similar to the one we played before. And that takes us, maybe this should auto increment when you beat a level. You all know this level, level 4, it's a little bit more complicated, but not by much. You can see I'm not playing efficiently here. Ooh. This is the next level. And then level 5, it's a little, just like showing a new kind of thing where you kind of have to like move things around. And then level 6, you can see it's a little bit more complicated, and level 7, a little bit more complicated. Okay, cool. So now let's see if it actually worked, which is our log.txt. And you can see we're loading levels. And yeah, this all looks good to me. Is it right? One thing I want to get rid of is the debug. So if we go to like object pool debug, we don't need that. We don't need that. So let's do that. Let's do Sokoban. Let's close and do this. So we did this on enter debug. So this is checking that. That's totally fine. Did it do the game level, or did I get rid of that? Level progression, go to game, on enter. I don't think I have the level progression saying what level we were in. Let me do it one more time. Okay. So let's see. You can see this kind of thing is happening now, which is kind of weird looking. You can see like Sokoban loading level is showing up when it really shouldn't be. It's showing up at the top every time. So we're using log info. So I think I know what the problem is. I don't know what the problem is. So we're calling our log function, but it's like it's getting flushed in the, it's basically what's happening is it's getting flushed in the incorrect order. So you can see like seconds played and loading, but like this is getting put to the top just for loading level. And it seems to be related to, well, one we have like there, that was weird. But it seems to be related to, what's confusing, right, is the log flush is after all this, so we really shouldn't be having anything like that. Log.txt, log.hpp, let's look at this. Because it's not info, right? Info is working. It seems to just be related to loading the level, which is of course wrong. Sokoban in it from level. And it's not like there's like some like weird double file thing happening. But there is some connection. Well, if we do like load seconds, for example, right, we're also using this. So let's start by just like doing debug, just seeing what happens. Okay. Loading level. I thought I changed it to debug. Did I not save it? Oh, I didn't make it. Classic. So we'll make it. Play. Now we'll look at it again. And now we're getting debug showing up at the top. All right, So this is one of those where we'll take a quick break and I'll just come back when I know what's wrong, because this is a weird one. All right, I'm back. So yeah, basically the bug was this: a global static variable in C++ is a static variable declared outside of any class or function. Unlike regular global variables, a global static variable has internal linkage, meaning it is accessible only within the file where it is defined. This ensures that its scope is limited to the current translation unit, preventing conflicts with variables in other files that may have the same name. So basically what was happening, as I understand it, was that when we were importing our logging file, we were reopening the file for different imports, essentially. So that's why when we loaded in for Sokoban, we were getting some different things, but when we were loading in for a menu, we were getting something else. And so basically what we were getting was the order of our log file was broken. So like if, for example, we added some way to like have the time, so we would add like seconds, microseconds, or whatever, some kind of formatting with date, time, seconds, microseconds, so we could actually see like how fast things were, which we should do at some point, but we'll come to that at a different point. But basically we're creating multiple versions of it. So the way to fix it, where if we do it like this, right, we go back to our ODR violation, so we can inline it, and that should solve it. So now when we do it, we can do clear make, and then in a second we'll be able to run it. It does take a surprisingly long time to run. What is it? 1,300 lines of code? Not that much. Anyways, doesn't matter. We can make a smarter build process anyways, where we like cache stuff and whatnot. We'll just load something, do this, quit, boom. Now we can go into the log, loading level, and you can see we did 0, we did 0.1, we did 0.2, player quit, player quitting, and that's the game. And yeah, so maybe at some point we'll, probably in another series, we'll get to where we actually add timestamps to all this, because that would actually make these logs a lot more useful, because we could say this shouldn't be debug, by the way, because I know we changed it while we were debugging, but that should be that. Okay, anyways, but basically if we had timestamps, we could say, oh, the user spent this long on playing this level, and then we could use that information. So if we wanted to catch cheaters, for example, and they took 0 seconds to beat a level, or like 0.0001 seconds to beat a level, we could say they're using like a keylogger or something. Anywho, that is the logger. We used perfect forwarding plus packing of arguments to be able to get this, which then allows us to, instead of having to do std format everywhere, we can actually do the formatting in the logging side of things, and everything's a lot better and cleaner, I think. So yeah, that is our little video on improving logging, and I'll see you in the next one where we get to ring buffers. And yeah, we're actually getting to the end of the series now, because after we do the ring buffer, we'll do a speed test, and then there's one other video, and then we should be moving on to the next project. So I'll see you in the next one. Bye.